So these are the three double angle formulas. Now these are not on the reference sheet, okay? They're not on the reference sheet, but you can work them out from the reference sheet. So sine of 2a, for example, that's equal to the same as sine of a plus a. So you can use the angle sum formula to work this one out if you forget it. So sine of a plus a, sine goes sine, cos, plus stays plus, sine, cos. Now because they're all a's, these are all a's, so you can see that's exactly the same thing. So that is 2 sine a cos a, exactly like I had written up there. Same thing for cos. Cos 2a is equal to cos of a plus a. Now, so that's cos minus sine. And you can see that is cos squared a minus sine squared a. Tan 2a is equal to tan of a plus a. And using that formula, in the numerator we add them, and in the denominator we do 1, so remember that sign's the same, this sign's the opposite, we do 1 minus the product, tan a, and so tan a plus tan a is just 2 tan a over 1 minus tan squared a. Now I would actually suggest memorizing those formulas. It's much more helpful if you can remember them because they're not on the reference sheet, but obviously there you can work them out if you need to. So let's look at this example. Given cos theta equals 4 on 7, find the exact value of sine 2 theta. So the first thing to do when you see one of these is to draw up a little triangle. So here's my theta, so this would be 4, this would be 7. By Pythagoras, this would be the square root of 49 minus 16, which is the square root of 33. Now we can use that. We know that sine 2 theta is equal to 2 sine theta cos theta. So sine theta is the square root of 33 over 7, and cos theta we already know is times 4 on 7. So if I work that all out, 2 4s are 8 root 33 over 49. In part B, we're asked to find the exact value of cos 3 theta from this same situation. So if you get 3 theta, the first thing to do is split that into theta plus 2 theta. So that would be cos theta, using the angle sum formula here, so cos minus sine theta sine 2 theta, and then you use your double angle formulas on those. So that's the same as cos theta times, now the cos double angle, remember, is cos squared minus sine squared. The first one is the same as because cos goes cos, sine, so cos first, then sine. So same one first. Minus, now sine 2 theta has a 2 in front, so I'm actually going to write that sine first. So I've got sine theta from this one, and then the 2 sine theta cos theta for that one. Now, we could, if we want to do some expanding and simplifying and that kind of thing. I'm actually just going to put in the values we know from our triangle. So our cos theta is 4 on 7. So that's multiplied by 4 on 7 squared, so 4 squared on 7 squared. And sine is root 33 squared over 7 squared. Minus, now there's sine times sine here, so I'm just going to do it as sine squared. So that's times, so sine was root 33 squared over 7 squared, times cos theta, which is 4 on 7. Now I just put that all in my calculator, and my calculator tells me that is negative 332 over 343. In question 2, we're going to show that cos 2x is equal to 1 minus 2 sine squared x. So let's have a go at that. So left-hand side equals cos 2x, and that's the same as cos squared x minus sine squared x. Now, here's the cool thing. We know that cos squared x plus sine squared x, this one's on the reference sheet as well, equals 1. Which means if I subtract a sine squared from each side of that, we know that cos squared x is equal to 1 minus sine squared x. So I'm going to replace this cos squared with 1 minus sine squared. And then I've still got that other minus sine squared x equals 1 minus 2 sine squared x. Now, you can actually do the same thing. Oh, so that equals right-hand side. We need our layout. Have a go at doing the exact same thing to show that cos 2x also equals 2 cos squared x minus 1. The proof is pretty much the same. It's just you're using sine squared equals 1 minus cos squared for that one. Okay, so I made a bit of a mistake. I'm just going to talk through what I had. I just started filming again from scratch. So these four formulas are called the products to subs and differences formulas, and they are on the reference sheet. I wouldn't expect you to memorize these because it's going to be a lot of time and effort to try and memorize those when they are provided to you. So I'm going to prove them. The way I'm going to prove them is just by expanding out the right-hand side. So you can see down here I've written the right-hand side for the first one, and what I've done is I've expanded these two out. So cos of a minus b is cos a cos b plus sine a sine b, and then cos of a plus b is cos a cos b minus sine a sine b. And my crossing out is because those two things are the same. There's a plus and there's a minus, just collecting like terms. And then cos a cos b plus cos a cos b is 2 cos a cos b, and the half and the 2 cancel each other down. Now, I was just starting this one when I made my mistake. There's my mistake there, that should be a plus. So this should be a minus. So we have cos of a plus b there. So let's start over here. So cos of a minus b, cos plus sine sine, minus cos of a plus b, so cos minus sine. So cos a cos b minus cos a cos b is nothing. And then I've got sine a sine b minus negative, so plus sine a sine b. So that becomes 2 sine a sine b, and that equals sine a sine b. So that's the second result up there. Just one little interesting thing about these results too, by the way. If you look at the last two, these ones here, they're just switched in the order, but the A and the B are switched as well. So these formulas can actually both provide something similar. So we've got a sign of a minus here. It's about being an odd function. They both work. They both give those results. Okay, so here's the third one. So that's equal to half of, so sine goes sine cos, the sign stays the same, so plus, and then the B and the A switch. So cos A plus, so sine A cos B, and minus, because for sine this stays the same. So sine, switch the B and the A. Okay, so let's see which terms we've got there that are the same that I can just cross out. So it's the sine B cos A that's minus. So here's sine B cos A. So they disappear. These two are the same, so half, 2 times. I'm just going to go straight to that sine A cos B. Half times 2 I haven't written down this time. Okay, so the last one is this one. So that's half of, so we've got sine cos plus sine, switch the A and the B, minus, so it's sine again, so sine A cos B. Sine is consistent with its pluses and minuses, so minus, switch the A and the B. sometimes I do actually write those in the reverse order. Instead of switching the A and the B, I write cos A, sine B. So I go sine, cos, cos, sine. But as long as it's the same, that's fine. So half of, I shouldn't have written the half of, let's do the same as I did on the previous line. So let's see where the minuses are. So I've got a minus sine A cos B. So sine A cos B minus sine A cos B. I'm minusing a negative, so I'm plussing. So sine B cos A plus sine B cos A is 2. Sine B cos A. Now, I did actually write it the other way around up above. I wrote the cos first. So half times 2 is just 1. And it's cos A times sine B. So that's those proofs. So let's look at this example to show how that can be used. So sine 75 cos 15. So the rule that went sine cos, I've just written it over here. So that's going to be equal to half of sine times the sum of A and B, so 75 plus 15, so sine 90, plus the difference of the two, so subtracting them. So 75 minus is going to be sine 60. Now, sine of 90, we can just put that in our calculator. We're right up here on the unit circle. Remember, sine is the y coordinate, so sine 90 is 1. So that's half of 1 plus sine 60, if we use our 60-30 triangle, then sine 60 is root 3 over 2. Now you could, if you wanted to, do a couple of things here. You've got two options. One is to expand it all out, one like that, or also it's nice to actually have it as one fraction. So let's get a common denominator of 4. So I'm going to put the 1/4 actually out the front. So I've actually pulled the half out instead. So this is like 2 times a half instead of putting it in. And I actually prefer that format for that answer. So this example asks us to write sine 2x, sine 5x as a sum or a difference. So that gives us the hint that this is the formula to use. That's sine sine, and this is sine sine. Now, technically speaking, the A and the B can go either way around. And because there's a difference in there, I'm actually going to turn this round first. So I'm going to say that sine 2x sine 5x is also actually equal to sine 5x sine 2x. And then I'm going to put it into that formula. So now my A is my 5x and my B is my 2x. So that's going to be half times cos of, I'll write it all out here, so 5x minus 2x minus cos of 5x plus 2x. So that's equal to half of cos, so 5x minus 2x is 3x minus cos of 7x.